Sao Paulo Metro Line 6 Orange is a fully underground rapid transit project that will connect Brasilândia in the northwest to São Joaquim in the city center, covering approximately 15.3 to 15.9 kilometers with 15 planned stations and will serve around 633,000 passengers daily. Operations will use advanced CBTC, communication-based train control, signaling provided by Nippon Signal, and a 750-volt DC catenary power system to ensure efficiency and reliability. CBTC is a railway signaling system that uses telecommunications between the train and track equipment for traffic management and infrastructure control. So why does this rail matter? Nicknamed the University Line, it will run through a few higher educational institutions and schools and connect to underserved northwest to Sao Paulo's core. The project will require complex utility, diversion work, and staged commissioning. This will not only improve connectivity between these areas, but economic participation as well. Key interchanges include Higienópolis-Mackenzie, known as Line 4. The Blue Line connects São Joaquim, while a major interface at Agua Branca will be linked by Line 7 and 8, connecting the West Side commuter rail with the metro grid. Because of the line, a trip that normally takes 90 minutes by bus has now been reduced to 23 minutes. After some financial and appropriation huddles in the beginning, the state signed a PPP with Acciona in July 2020, giving the company rights to construct and operate the rail line for 19 years. The ownership of the line, however, will be kept public. Acciona has invested 19 billion Brazilian real, approximately 3.5 billion United States dollars. Up to date, Line 6 is the largest construction project in the history of Latin America. The development of Line 6 has been marked by planning challenges and restarts. Between 2008 and 2014, for example, the project went through planning, design development and expropriations, only to be discovered that the project schedules were too ambitious. Construction officially began in 2015, but by 2016, works were suspended due to financing difficulties. In February 2022, progress was temporarily disrupted by a sinkhole that appeared near Marginal Tietê, prompting safety reviews and adjustments to the project's schedule. Despite these setbacks, the current plan still calls for a staged opening. The first section between Brasilândia and Perdizes is expected to begin operating in 2026, while the full line extending to São Joaquim is scheduled for completion and opening in 2027. This phased approach reduces risk while delivering benefits earlier. It also allows for testing and systems integration of power, CBTC, and platform screen doors, among other things. Remember to check out the links in the description for more useful information. Sao Paulo Metro Line 6 employs a combination of mechanized tunneling and conventional excavation techniques to address its complex urban conditions. The project uses massive earth pressure balance, EPB, tunnel boring machines, TBMs, each approximately 10.61 meters in diameter, 109 meters long, and weighing around 2,000 tons. One TBM was used for a 10-kilometer southern stretch, passing through about 10 station boxes between Santa Marina and São Joaquim, advancing at a rate of 12 to 15 meters per day under multi-shift operations. A second TBM was launched for a 5.3-kilometer north stretch. Where tunnel boring machines could not be used, the new Austrian tunneling method, NATM, was applied particularly for station caverns, cross passages, and geometrically constrained sections. This is a flexible, modern tunnel construction technique that uses sophisticated monitoring to optimize temporary and permanent support systems based on specific geological conditions. Under this method, initial support is provided in the form of shotcrete, which is applied immediately after excavation. The inherent strength of the surrounding rock is used to bear loads. Ground deformation is continuously monitored to guide subsequent support measures. The method developed adapts the support system as tunneling progresses, making it suitable for various ground conditions. All the stations on the line will be all underground, featuring side island platforms equipped with platform screen doors. Stations like Higienópolis-Mackenzie, Perdizes, PUC Cardoso de Almeida, and FAAP Pacaembu will serve areas with many university students. The line will operate on a standard gauge track measuring 1,435 millimeters, using a 750-volt direct current overhead, a catenary system, which is consistent with Sao Paulo Metro's approach on new deep-bore lines. Its electrical infrastructure will include substations, rectifiers, and SCADA systems, all integrated with the concessionaire's operations and maintenance framework. The advanced signaling used by the rail line will increase line capacity. For example, it will enable headways of under 120 seconds during peak periods while providing flexibility for dynamic regulation in the event of disruptions. Alstom is supplying 22 6-car Series 600 Metropolis trains from its Talbot plant. The trains with stainless steel car bodies can carry up to 2,044 passengers per train and travel at a 90 km/h design speed. Line 6 Orange is projected to carry approximately 633,000 passengers daily once it reaches full operation. Operationally, the line's use of CBTC signaling and 6-car Alstom Metropolis trains will allow service frequencies to be scaled efficiently in response to passenger demand. Platform screen doors and well-designed vertical circulation systems at stations will help maintain short dwell times, ensuring smooth passenger flow even during peak hours. Together, these features position Line 6 as one of Sao Paulo's most impactful mobility projects, enhancing connectivity and quality of life across the metropolitan region. Ground and settlement risks are mitigated through extensive probe drilling, EPB conditioning foam management, and continuous volume loss monitoring. Interface risks among civil works, MEP systems, signaling and rolling stock are addressed via strict configuration management, staged energization, and sectorized testing. Additionally, rolling acceptance of trains facilitates early driver training and software testing. This integrated approach combines rigorous engineering practices with operational planning to reduce risk and maintain ambitious performance and safety targets. This project offers several instructive lessons for civil and transit engineers. The 2020 PPP restart illustrates how bundling design, construction, finance, operation, and maintenance under a single contract can accelerate stalled megaprojects and improve life cycle quality. Employing TBM in Sao Paulo's challenging geology was not easy, and required complex urban tunneling, segment production, and logistics management. Staged commissioning before full line opening provides early operational benefits, such as real-world testing for CBTC, platform screen doors, and depot workflows, and mitigates risks that may stem from a big launch opening. Finally, system-wide connectivity multiplies project value. Interchanges with lines 1, 2, 4, 7, and 8 will relieve surface congestion, redistribute demand, and create a transformative node at Agua Branca for West Corridor rail-to-metro transfers. Line 6 exemplifies integrated engineering, risk management, and urban mobility planning. As of mid-2025, Sao Paulo Metro Line 6 Orange has achieved several key milestones. TBM operations have successfully connected the running tunnels end-to-end at São Joaquim. Civil works are progressing with station boxes and caverns in advanced stages while secondary linings, mezzanines, and MEP installations continue. The project remains on track according to state and concession updates. These developments reflect a complex, well-coordinated effort across tunneling, civil construction, and systems integration, demonstrating the scale and technical sophistication of one of Sao Paulo's most significant metro expansions. Special attention must be emphasized on both technical and strategic lessons. Geotechnical conditions govern tunneling and construction. Therefore, continuous monitoring and contingency plans are essential, as illustrated by the 2022 Marginal Tietê incident. Integration challenges at station interfaces such as utilities, rail systems, and commissioning often pose the greatest challenges. Finally, staged delivery is a deliberate strategy rather than a compromise. Opening initial segments early mitigates risk, allows for learning, and smooths commissioning for subsequent sections. These lessons illustrate the importance of proactive risk management systems integration and strategic planning in modern urban metro mega projects. Thank you for watching. Remember to subscribe and see you in the next video.